Hello everybody, and welcome to a pre-AP geometry lesson. If you can hear this, it means that I am at home and sick. So unfortunately I won't be here with you today to go over these very exciting Unit 3 notes. However, these notes should serve to get you caught up to speed. So without further ado, let's begin. Unit 3, Lesson 2 is going to be all about rotation rules. And the first thing we need to figure out is how to actually rotate something. I mentioned that for this class we were going to need a compass and a protractor, and my statement stands. There is no way to really rotate with just a compass. You can do it for certain angles, but not for all of them, and the process is quite complicated. So instead, here's how we are going to do it. For starters, let's call this point O and this one point P. In order to rotate this, we want to start by making line segment OP. Right? From here, we can actually use our protractor to measure out exactly what 45 degrees looks like. So as a reminder, here's how you use your protractor. Line up the center of your protractor where you see that horizontal line. For some of you, it may be the bottom of your protractor. Line it up on the center of rotation. Adjust it so that it just perfectly covers up the line to point P. Unfortunately, my line was not perfectly straight, and that's why you see it a little wobbly. And you're going to want to mark off 45 degrees. To do so, take a look at these numbers. We know that 45 degrees is an acute angle, so we don't want to use the big numbers over here. We want to use the small numbers. To mark this off, make a small tick mark at 45 on one end, and at 135 on the other. By going on either opposite end of the protractor, it gives you the opportunity to make a straight line. So if I connect up these two tick marks, let's just do it right this time. Perfect. What we've done is we've created a 45-degree angle. Problem is, we don't really know where point P should be along this angle, and that's where we use our protractor. The protractor can be used to measure out the distance between 2 points. So adjust your compass so that it just measures out line segment OP. And then, while keeping your needle at point O, take your compass and make an arc that goes across the line you just drew. This intersection right here is point P prime. And we have just rotated point P 45 degrees. The same can be said when you have 3 separate points. Now bear in mind, here we are told to rotate 60 degrees counterclockwise. This is the same direction that we've been going. And in fact, when you're asked to rotate, most of the time it's going to be counterclockwise. The reason is that's the same direction that our quadrant system goes in. If you recall, there are 4 quadrants of a graph, and that also goes counterclockwise. So we are going to try to rotate ABC 60 degrees counterclockwise. Please pause the video here and see what you can do. How'd you do? If you rotated your figure 60 degrees counterclockwise, it should look something like this. All right, here's what I'd like you to do now. The substitute teacher should have an exploration about rotations handed out to you. I want you to use this exploration as a testing grounds. And just like before, the goal is just to find the rule. If you can find the rule, you don't need to finish the exploration. Your goal is to write down what each transformation is, make a verbal description of it, and then write the algebraic rule in function notation. Pause the video here and see what you can do. Hopefully by this point you've had a chance to try out the rotations exploration. Here are the rules. Each time you rotate 90 degrees, what really happens is that you're just swapping the x and y and throwing a negative down on the first coordinate. So when you rotate just 90 degrees, you get negative y, positive x. When you repeat the rotation, again, you're just rotating another 90 degrees. So we swap these two once more, and then we get negative x, negative y. Again, another 90-degree rotation just involves swapping the x and y and making the first one negative. So when we swap these two, we would get negative y, negative x. But putting a negative on there, negative, negative y, just turns it back into y. So in short, rotating something clockwise gives you the coordinates, or gives you the rule, I should say, y comma negative x. Because remember, we as a default like to rotate things counterclockwise. The rule for counterclockwise is going to be our first rule here, negative y comma x. 180 degrees, you just swap the x and y and make them both negative. What I'd like you to do now is this. I'd like you to try out problems A through F in exercise 1. But I will be discussing them here with you all. I'll do one of them here, and then you'll be able to try out the rest. So, first things first. How do we identify what rotation is going on here? Well, let's take a look at problem A. Really, any place is a good place to start. I want to start with point M. Let's see what changes about point M. Point M is originally at 3, 4. M prime ends up all the way down here at negative 3, negative 4. Odd, okay. D. D is all the way over at at 5, 4. D prime is at negative 5, negative 4. I think we're starting to see the picture here, but let's do points P and W just in case. Point P is at 5, 0. P prime, though, is at negative 5, 0. There's no negative variant of 0, so that makes sense. W is at 2, 0, and goes to W prime, which is at negative 2, 0. So, which rule is happening here? Well, according to our list, this is a 180-degree rotation. You would normally have to write down clockwise or counterclockwise, but because it's 180 degrees, it doesn't actually matter where it does so. But you also want to write that it's done about the origin. All these rotations that we've learned so far have been done around the origin, or around 0, 0. That might not always be the case, though. So, I want you to pause again. I know it's a lot of pausing. Try out exercises B through F, and unpause when you're ready. Hopefully by this point you have finished problem 1. This is as good a time as any to remind you all that the answer key to these notes are found on Canvas. Just go to our big calendar, and there's the answer key right there ready for you. You can check with the answer key to see how well you did, but I want to discuss problem number 2. So problem number 2 says to graph the new image using the given transformation. As a reminder, the shape you have before doing a transformation is called the pre-image. The image is the name we give to the shape after you do the transformation. We have to list both the original and the new image's coordinate points. So let's start off with this, a rotation 180 degrees about the origin. Well, we know the rule for 180 degrees is that we just keep the x and y in the same order, but we make them both negative. So all we're going to do is take these coordinates and simply make them both negative. So let's see what we've got. T's original coordinates are at negative 3, 4. If we make both of them negative, we get positive 3, negative 4, because two negatives make a positive. J already has two negatives, negative 2, negative 1, so when we double negative them, we end up with J prime at 2, 1. Finally, Z is going to be the easiest point to rotate of all because it's actually at the origin. Any rotation about the origin with a point that's at the origin is just going to stay at the origin. So when we graph these new coordinates, we get T prime, which is all the way right here. We get J prime, which is all the way up here. And Z prime is just right where Z was. We just got to connect them. And we will end up with a 180-degree rotation. There we go. Once again, practice makes perfect, and these are going to be rules that we eventually memorize. So, I do, once again, want you to try out B, C, and D, and then after which point we will have a chance to go over some new content. Once again, pause the video and try B, C, and D. Hopefully did pretty well with that. Again, the answer key is on Canvas. Now, there are two directions of rotation as well. There's clockwise and counterclockwise, as we've already discussed. Counterclockwise is the one that mathematicians by default will use. However, you can see it used both ways. As a reminder, all we're doing when we rotate is just like what we did when we constructed a rotation. We treat a rotation like making a ray from the original point to the center of rotation, and then rotating that ray over. This allows us to do pretty cool things, including checking whether or not something is actually a rotation about the origin. So here's how to check if something is a rotation about the origin. And we're going to see what happens when you don't have an origin rotation here in a moment. First things first, we're asked to graph AB and CD. So A is here, B is here, there we go. C is right here at 1, 3, and D is at 3, 1. So, to check if something is a rotation or not, we just need to see if it follows the rules. Think about this rotation here. If we're rotating from A, B to C, D, that's going to be a 90-degree clockwise rotation. And how do we know it's 90-degree clockwise? Because we go from quadrant 2 to quadrant 1. The entirety of these points change quadrants. So, let's see what we can do here. Originally, we know that A is at -3, 1. So, its transformation should be at, well, for a 90-degree clockwise rotation, switch the x and y and make the y negative. So, we would end up with 1, 3. Wait a second, those are the coordinates of point C. A prime is just point C. What about B? Well, point B is at -1, 3. If we switch the order, and again, make the y value positive, we get 3, 1. Wait a second, 3, 1 is just point D. So B prime is just point D. This transformation is, in fact, a 90-degree clockwise rotation about the origin because the points map 1 to 1. Mapping means they lay on top of each other. Now, while I will leave you with problem 4 to do, I do want to discuss briefly this last example here. How to find the angle of rotation and how to find the center of rotation without your point being at the origin. Here's what you're going to do. First off, you have to have the rotation already done. So that does mean it's a little bit restrictive. What you're going to do is you're going to actually construct the center of rotation here, then use rays to find the angle of rotation and its direction. Start off with a point and its transformed point, a pre-image and its image. This is where we're going to construct our first line. I'm doing it with B and B prime. Second, we need to construct the perpendicular bisector of these points, a thing that we have discussed in the past. To construct the perpendicular bisector, as a reminder, what you're going to do is take your compass at one of the points, measure it out so it's just over halfway across. The closer the better. And you're going to make, whoops, my compass slipped. You're going to make 2 arcs. One at one of the points, and one at the point on the other side. What you should see, whoops, my compass is slipping all kinds of different ways right now. What you should see is there's 2 spots where the lines cross, where the arcs cross, I should say, here, and that's where you're going to construct a perpendicular bisector. This is the line that is perpendicular and cuts the line in half. Sorry about the delay there, folks. It seems that my last video got cut off. As we had said, we want to make a perpendicular bisector between B and B prime. If you're trying to find the center of rotation, though, you just need to make another perpendicular bisector between any two other points. So I'm going to go between C and C prime just because those are the most accessible right now. As a reminder, once again, we extend out our compass to just past the halfway point. I'll say about there. We want to make our arcs. So here's arc number 1, if it didn't slip. There we go. And here's arc number 2 on C prime. And once again, you'll see that we have a perfect perpendicular bisector by connecting up these points. Now, I've intentionally made these perpendicular bisectors pretty long because the spot where they cross, X does in fact mark the spot. This is where our center of rotation is. Center of rotation. So that's where we must be rotating around. And if you were to take a look at this shape, if I was to turn it almost upside down, you can almost see that this triangle was moved this way with this as its center. That's how you find the center of rotation for when your center is not at the origin. However, if you want to find the angle of rotation, that's going to be a reconstruction of one of the constructions we did earlier. All you're going to do is try to figure out the angle between your center of rotation and one of your original points and its transformed point, the pre-image and the image. I'm going to erase all this so it's a little more clear to see, but realistically on a test you'd want to keep all of your construction work. If we go here, and if I try and find, for instance, the angle of rotation between point A and point A prime, all that involves is making two lines, one from A, one from A prime, lining up my protractor, and in fact I'm going to have to extend out my A prime line a little bit. Extend it out, and then just find what that angle is. And it looks to be, as I adjust my protractor here, about 52 degrees. So I would say this is about a 52-degree angle of rotation. That's it, everybody, for the Unit 3 Part 2 notes. Have a fantastic rest of your day.